For our last video in this unit, we will talk about how delta G will change with temperature and whether or not a reaction will be spontaneous depending on the value of delta H, delta S, and the temperature. So we have to remember that we have our delta G equals delta H minus T delta S formula. All right, so if you remember from Regents, when we had an exothermic reaction or negative delta H and an increase in entropy, that produced a spontaneous reaction. So if we put in a negative delta H and a positive delta S, that helps us get a negative delta G. So that's what we call our perfect scenario situation that will always have a spontaneous reaction. Now on the flip side, never spontaneous, regardless of what the temperature is, would be the opposite. So if delta H is greater than 1 and delta S, entropy, is decreasing, that will never, ever, ever be spontaneous regardless of the temperature. Then we have where we hit on one factor but not the other, and then it will depend upon temperature. So this one will be spontaneous sometimes, and we'll figure out at what temperature in a moment. So if delta H is negative and delta S is also negative. So if we go back up here to our equation, if we put in a negative for delta H and a negative for delta S. So basically, this is the term we wanted, and we didn't get the delta S that we wanted in order to be spontaneous. So we want to minimize this delta S term, so this would be spontaneous at a low temperature. So then our last scenario would be when we have delta H being greater than 1 and delta S also being greater than 1. So we would be putting in a positive for delta H and a positive for delta S. So we did not hit on the always scenario for delta H. Super cheesy, but this really helps. So that's not the term that we're happy with. We did get the value that we wanted for delta S. That helps us get the negative delta G. So that's the term of the equation that we want to maximize. So that would be maximized if temperature is higher. So what we have to memorize is our always spontaneous scenario. Then the reverse is never. If you have one or the other, look at if you're trying to maximize the temperature term, then that would be a higher temperature. Or if you're trying to minimize the T delta S term, then that would be spontaneous at a lower temperature. You also could memorize this table here that would tell you when they are spontaneous, and it's basically the same thing that we just did. So delta H is negative, delta S is positive. That makes the T delta S term negative, making delta G negative, and that would be spontaneous at all temperatures. The reverse is never. And again, if both delta H and delta S have the same sign, it may be spontaneous depending upon the temperature. All right, so with this example, we are going to calculate delta G using delta H minus T delta S for both 75 degrees Celsius and 125 degrees Celsius. Since we have been given the individual heat of formations and delta S values, we'll first find delta H, then find delta S, then plug it into the formula. All right, so the first thing that we'll do is we'll take the values from the previous slide and calculate the delta H of the reaction using the sum of the products minus the sum of the reactants. All right, so if we plug in our values, the heat of the reaction would be 44.01 kilojoules, which makes sense that it would be endothermic because it's boiling or evaporation, so it would take energy. All right, so then if we do our calculation for delta S, we get 118.9 joules per Kelvin or 0.1189 kilojoules per Kelvin. So then we can plug those into the delta G equation. All right, so the delta G at 75 degrees Celsius, which would be 348 Kelvin, works out to be positive 2.63. Therefore, that would not be spontaneous, which makes sense because it's H2O liquid going to H2O gas at 75 degrees Celsius, and that is not going to occur spontaneously. However, when we calculate that same delta G, but this time at 125 degrees Celsius or 398 Kelvin, then we get a negative value, negative 3.31 kilojoules, indicating that the reaction would occur spontaneously, which will make sense because at 125 degrees Celsius, water would spontaneously turn into the gas phase. And had we actually calculated delta G at 100 degrees Celsius, delta G would have a value of 0, showing that it would be at equilibrium because that's where the phase change will occur.